In this lesson, we're going to look at multiplying and dividing expressions with common bases. And sometimes instead of using the word common, we'll sometimes use the word like. So like bases, common bases, and you'll see what we mean by that as we go through the lesson. But one thing that's important, though, in order for you to be able to successfully understand every part of this lesson is that you need to remember something about exponential notation. So let's kind of define or recall what the definition of b to the n is. So b to the n. So remember that when we talk about this exponential notation, b to the n, the b is called the base. So the base is b, and n is the exponent. Okay, so the base is b, and n is the exponent. So as you go through this lesson and future lessons, make sure you understand what the base is and what the exponent is. So b to the n, this notation here is defined to be this. B to the n is defined to be b times b times b, and so on. So it's b times b times b. So be the product of b in factors. So n times. Okay? So n factors of b. So I need n factors of b here. So for example, if I had 2 to the third, just like this, 2 to the third, so the base is 2, the exponent is 3. What that means is that I'm multiplying 2 by itself 3 times. So the exponent tells you how many factors of 2 you have. The exponent's n, I have n factors of b. Okay? So that's how you understand or make sure you know the definition of 2 to the b as being 2 times 2 times 2. All right, because the exponent is 3 and my base is 2. Okay? Now, if you multiply that out, 2 to the third is going to be 2 times 2 is 4. 4 times 2 is 8. Okay? All right, so let's look at this one. If I have, so let's call this A right here. So A. Then B, let's say we had 1/3 to the 4th power. 1/3 to the 4th power. Well, 1/3 to the 4th power is same idea. So 1/3 is the base, 4 is the exponent. So I have 1/3 times 1/3 times 1/3 times 1/3, right? So notice I have 4 factors of 1/3. So I have 1/3 listed 4 times. That's the exponent. That's how many factors of the base you are multiplying by itself. So these are all multiplication symbols. And then when I multiply this out, the numerator, you have 1 times 1 times 1 times 1, which is 1. The denominator, 3 times 3 is 9. 9 times 3 is 27. And then 27, if you need to use your calculator, 27 times 3 is 81. All right, so 1/3 to the 4th power is equal to 81. Okay, now be a little bit careful sometimes. If I have, let's say, negative 1/4 to the 3rd power, negative 1/4 to the 3rd power, be careful. Remember what that means is negative 1/4 is the base, right? So that means I'm going to multiply negative 1/4, excuse me, times itself, the exponent number of times. So notice negative 1/4 times negative 1/4 times negative 1/4. That's 3 times. You see that? The exponent matches. So multiplying this out, a negative 1 times a negative 1 is a positive 1. A positive 1 times a negative 1 is a negative 1. The denominator, 4 times 4 is 16, and then 16 times 4 will give you 64. So the answer is negative 1 divided by 64. Okay? And you could deal with decimals as well. So for example, if I have D being, let's say, 0.4 to the 4th power, all right, 0.4 to the 4th power, so that's 4/10 to the 4th power. So the basis is 0.4, right? So that's going to be 0.4 times, I'm making the multiplication a little bit larger. So that's 0.4 times 0.4 times 0.4 times 0.4. Now I just want to say something. So you see how there's a lot of dots here, a lot of points. So it's when you have a decimal, it's usually easier, or it's usually preferable, I should say, that you put those in parentheses. So we have 0.4 times 0.4 times 0.4 times 0.4. So that way there's no confusion. Okay? So that decimal point here represents a decimal point and not multiplication. So 0.4 times 0.4 times 0.4 times 0.4. And then when you multiply that out, so 0.4 times 4 will give you, So 0.4 times 0.4 times 0.4 times 0.4 gives you this. It's going to be 0.0256. And all I did was I used a calculator. Because doing this by hand, 0.4 times 0.4 is 0.16. Then you have to do that times 0.4 and continue on. So I just, for time purposes, I just used a calculator. 0.4 times itself 4 times. Okay? All right. So that's it. So notice the base is 2, right? Here the base is 2, and the exponent is 3, right? And make sure you understand what that means. So when the base is 2 and the exponent is 3, that means 2 times itself 3 times. Here the base is 1/3, right? Base equals 1/3. Exponent equals 4. So what that means is that 1/3 is being multiplied by itself 4 times. Okay, so make sure you understand all of that. Now, one other thing I got to mention, and sometimes students get a little confused, is this. So make note of this. If you see something like 4 times y to the 6th power, 4 times y to the 6th power, see the exponent here is 6, right? The exponent here, 6, represents the exponent of y. So you may say, well, what is the exponent of 4? Well, remember, if there's no number there, it's that implied 1. So that's the same thing as saying 4 to the 1st times y to the 6th. So this and this mean the same thing. So some students make the mistake and think that 4y is being raised to the 6th power. 4 is to the 6th and y is to the 6th. That's not true. 4 is being raised to the 1st power. Y is the one that's being raised to the 6th. All right, so be careful as we go through these lessons. Now, the other thing you need to know is this. You need to know how to evaluate expressions with exponents. Okay, so evaluating expressions with exponents. As we go through these topics, it's very important you listen carefully to the notation and words that will follow. All right, so listen to this carefully. Let's go ahead and evaluate the following. So I'm going to call this one letter A. So let's suppose in letter A I have negative 3 to the 2nd power. Okay, negative 3 to the 2nd power. Well, based on what we just talked about here, with all of this information, negative 3 to the 2nd power, remember the base, so remember the base here is negative 3, right? And the exponent is 2. So what that means is that negative 3 is being multiplied by itself twice. Negative 3 times negative 3. Well, what is negative 3 times negative 3? Well, negative 3 times negative 3 is a positive 9. Notice positive. All right, so any negative number raised to an even power better be positive. So if you're going to use your calculator as we go through the process, you need to make sure that when putting this into your calculator, this is inside parentheses, because notice what some students are going to do. Some students are going to say negative 3 squared. So I want to show you something. Negative 3 raised to the 2nd power. See, no parentheses, right? When you press enter, that's a negative 9. What's happening is that you're only squaring the 3, and then 3 squares 9, and then you're making it negative. But that's not what this says. This says negative 3 times itself. So you got to put that in parentheses. So parentheses negative 3, just like this. Now you square it, and you get positive 9. So make sure make sure you understand that the base is negative 3 here. And you're multiplying it by itself twice. Okay? Now, don't confuse that with something like this. What if I had negative 4 squared, like this? Notice there's no parentheses there. So negative 4 squared versus negative 4 squared in parentheses. Those are two different things. Here, the base here is negative 4. Here, the base of what's being squared is a positive 4. Base is 4 here. So you got to be careful. What is being squared? Let's do this one. What is being squared here? A negative 4. So that means negative 4 times negative 4, which is 16. Positive 16. Here, what's being squared? Well, what's being squared is this 4 only. So that becomes negative, and then 4 is being squared. 4 times 4. So your base is 4. Base is 4, so cover the negative up. Base is 4, cover this up. 4 squared means 4 times 4, right? Which is 16. But then there's a negative out there, so that means the opposite of this. So the opposite of 4 times 4 is a negative 16. Okay? So be careful. You're going to see this throughout these lessons that we're going to look at. All right, now let's look at this one. So C, suppose you had negative 0.2 to the fourth power. Negative 0.2 to the fourth power. All right, so first of all, notice that the negative 0.2 is inside parentheses, right? And so the base is negative 0.2. I want you to remember we just talked about a negative number raised to an even power better be positive. So when we look at this, negative 0.2 times negative 0.2 times negative, times negative 0.2, and that's 4 times. 1, 2, 3, and one more. So when I multiply this out, 0.2 times 0.2 times 0.2 times 0.2, first of all, let me say this. A negative times a negative is a positive times a negative is a negative, and then a negative times a negative is a positive, right? Okay, so I know I'm going to get a positive answer here. But 0.2 times itself 4 times, 0.2 times itself 4 times gives us this, 0.0016. All right, so this is what you're doing. You can put that negative 0.2 in parentheses, but it's important you don't rely on that calculator. You got to understand that negative 0.2 means this, because there might be some questions about what does this mean, okay? And now since that's a bunch of decimals here, if you look at the calculator, so in parentheses, negative 0.2, just like I have here, close parentheses, and that is being raised to the fourth. I want you to notice that's 0.0016, or 16s, tens, hundreds, thousands, 10 thousandths. So 16 10 thousandths. Okay? D, what if you had this? Negative 0.2 to the third power. Negative 0.2 to the third power. Well, remember there's no parentheses, right? So what that means right here, this right here, if you cover the negative up, what that means is that the only number that's being raised to the third power is 0.2. So 0.2 is your base. So this let me write it this way. This becomes 0.2 times itself 3 times, right? But remember, there's a negative out in front, so you got to put a negative here. You got to bring that down. And so 0.2 times 0.2 is 0.04, and then 0.04 times 0.2 is 0.008. So it becomes a negative 0.008. Okay? Now, remember when I said that any negative number raised to an even power is going to be positive? Don't overgeneralize this. So if I have something like E, and I said, what is negative 1/3 to the third power? Notice I have a negative number raised to a power, right? But that's an odd power, not even. So a negative number raised to an odd power is going to be negative, because your base is negative 1/3, so negative 1/3 times itself 3 times. A negative times a negative times a negative is a negative. 1 times 1 times 1 is 1. 3 times 3 is 9. 9 times 3 is 27. Okay? All right. So that's very important. It's very important for you to know the difference between what if I have parentheses and then what if I don't. Okay? That's different ideas. Okay. Now, the next thing, still dealing with evaluating expressions. So the first thing we need to do is notice that these expressions here did not contain any variables. You have negative 3 squared, that can easily be done. You had negative 4 to the second power, which you know is negative 16, and so on. What I'm going to do now is evaluate the following where we have variables. All right, so let's look at that. So that's going to be the next set of problems. Okay, so in this example, in the next example we're going to look at, the directions will say evaluate each expression where a is 3 and b is negative 4. So for example, if I have, let's say, 3a to the second power, 3a to the second power, what that tells me to do is in place of a, I'm going to substitute what a is. So a is 3. So this becomes 3 times 3 squared. So in place of a, I'm going to substitute what we're indicating a needs to be. So a is 3. And now I'm going to use the fact that what's being squared is 3. So I get this 3, be careful how you write it, times two factors of this 3. So 3 times 3 times 3. So this 3 comes from here, and then these two 3's come from this part of the expression. So 3 times 3 is 9. 9 times 3 is 27. So the answer is 27. Okay? Let's look at B. So in B, let's suppose you had negative 6 times a times b to the second power. So negative 6 times a times b to the second power. So I want to evaluate this expression when a is 3 and b is negative 4. So be very careful how you substitute. So here's the way I'm going to do this. So I have negative 6, that factor, times, and put this a in parentheses. So a is 3, just like this, times in parentheses b, which is negative 4, but negative 4 is being raised to the second power. So again, look, this is a and this is b. Notice I put all those in parentheses so I don't mess up. Okay? Just like I did here, I put that in parentheses so I don't mess up. It's a very good idea to do that. Now, when your variable is negative, when your base is negative, you need to put that in parentheses because what's being squared is the negative 4, so that needs to be in parentheses. All right, now let's use the order of operations. Remember, the order of operations says I have to do exponents before multiplication. So let's look at this right here. So right, I have so far as this, negative 6 times 3 times negative 4 times negative 4, right? So what I did was I just rewrote what this little part means. So this part here that I'm looking at indicates that I have two factors of negative 4. So I've got to multiply negative 4 by itself twice. And so now let's go ahead and multiply this out. We're going to need a calculator here because it's going to take too long to multiply that out. But you would have to say negative 18 times a negative 4 and then go from there. So let's just use the calculator. Negative 6 times 3, and I'm going to put that in parentheses like I have it so you don't get confused. So negative 6 times 3 in parentheses times negative 4, just like this, times, and then in parentheses negative 4 again, okay? And then equal, and you get negative 288. So that's negative 288. And I know it has to be negative because, look, a negative times a positive is a negative times this negative is a positive, and this positive times this negative is a negative. Okay, so that's negative, I didn't mean to put a decimal point there, that's negative 288. Okay, all right, now let's look at another one. So let's look at C. So in C, let's suppose you have A plus B to the third power. Let's say we had that. A plus B to the third power. Okay, so in place of A, I'm going to substitute 3. And in place of B, I'm going to substitute -4. All right, so I get 3 plus B, which is a -4, and all that's being raised to the third power. All right, let's kind of simplify that parentheses first. I know what 3 plus a -4 is. 3 plus a -4 is a -1. But the -1 is being raised to the third power. Now let's talk about what that means. So -1 to the third power means -1 times itself 3 times. And I don't need a calculator here because I know that a -1 times a -1 is a +1, and a +1 times this -1 is a -1. All right. Okay, so that's one example. Let's look at another example. Okay, so in this example, we're going to evaluate each expression. This time x is 2 and y is -6. So let's suppose we had this one. So let's call this letter A. So in letter A, let's suppose we had -2 y to the third power. -2y to the third power. All right, so in place of y, I'm going to substitute -6. So I get -2 times -6 cubed. Notice y is -6. See that? Just like this. But -6 being cubed. Okay? And so what that means is -2 times -6 times itself 3 times. That's what this means. This right here means this. And then it's just a matter of you using your calculator to do this. So first of all, notice that a negative times a negative is a positive times a negative is a negative, and then a negative times a negative is a positive. So the answer should be positive. Now, when using your calculator, just remember, you make sure you know how to use your calculator, the exponential buttons and the parentheses. See how it looks like -2 times in parentheses -6 to the third? So when you do that, -2 in parentheses, -6 parentheses, close the parentheses, raised to the third, your answer should be 432. Okay? So that would be 432. All right, in part B, let's suppose we had 3xy. All right? So I want you to notice that the exponent of x, since there's no exponent there, that's an implied exponent of 1. Same thing for y. So when I substitute, I get 3 times x is 2, right? And then y is -6. Now that's easy to do without using a calculator. 3 times 2 is 6, and then 6 times -6 is a -36. That's the answer there. Okay. Letter C, suppose you had y minus x to the second power. Let's say we had that. All right, y minus x. All right, so in place of y, you're going to substitute -6. In place of x, you're going to substitute 2. So here's what we get. We get in parentheses, we have -6 subtract x, which is 2. -6 subtract, and this is x, see that? Which is 2. And then that's being squared. So inside the parentheses, a -6 subtract -2. Remember that means -6 subtract -6 subtract 2. If you need to change subtraction to addition, you do that. So what that means is -6 plus the opposite of 2, which is -2. That's a -8. So this becomes -8 squared. And -8 squared is easy to do without a calculator. That means -8 times itself. So a -8 times a -8 is a +64. Okay? D. Now, suppose I had this for D instead. Instead of saying y minus x, let's suppose we had x minus y squared. What will be the difference? Well, let's look. So x is listed first, so be careful. So that's 2. So you're going to say 2 subtract y. Y is -6, just like this, and that's being squared. Be a little bit careful with this one. That's 2 subtract -6, right? that's inside the parentheses? Well, if I change this to addition, adding the opposite, you add the opposite, that becomes 2 plus, and then the opposite of a negative 6 is a positive 6. So that becomes a positive 8 this time. And so 8 squared means 8 times 8, which is 64. Okay? All right, so that's basically all I wanted to do with this part of the lesson. And so in this part of the lesson, we learned how to do several things. So we learned how we looked at reviewing the idea of exponential notation, and we also looked at how to evaluate expressions involving exponents. And in this case, we had variables involved where we had to substitute in place of the variables the values of them. All right. Now in the next part of this lesson, we're going to look at multiplying and dividing with like bases. So what does that mean? So again, to this point of multiplying and dividing like bases. Okay, so that's going to be the next part.